Alright, so let's go ahead and get started here. The first couple of equations, those are like the ones we did yesterday because, well, why are they like the ones we did yesterday? You guys tell me. So those equations have, they actually only have one variable, but the variable's in different places, right? So those are the types of equations that we saw yesterday, where when the variable's in different places, we have to get it into one place before we can get it by itself. So our goal is to get a by itself here, but it's hard to get it by itself when it's in two different places. So we're going to have to deal with that. So in this first equation here, what am I going to do? Okay, so we'll start by circling the variable, and circling the variable in this case just shows us that we have the variable in different places, and we're going to have to deal with that. So I do want to get a by itself. So what do I need to do first? Do I need to distribute? That's the first thing it says to do in our notes. Is there anything to distribute here? No. All right, so then what? Combine like terms. Do we have any like terms here?
Yes.
Yeah, the 3a and the negative 5a, right? What is 3a minus 5a? Negative 2a. All right, so we combine our like terms and we get negative 2a there. Can I combine the 7 and the negative 1?
No.
Why not? They're on opposite sides of the equal sign. So even though they're like terms, we cannot combine those. So what do we do with them? Subtract 7 from negative 2a?
No.
We're not done with that first step, guys. What do we need to do? Yeah, we need to bring everything else down, right? So make sure that each step along the way you simplify and you get a new equation. So we're going to bring down that plus 7 on the left side and the negative 1 on the right side. Okay, now we can move on to the next step. Now the a is in one place, so we can get it by itself. So what do I need to get rid of first? The negative 2 or the positive 7? Okay, and how do we get rid of the plus 7? Subtract 7. All right, so we'll subtract 7 on both sides. On the left side, when those 7s cancel, what does that leave?
Negative 2a.
All right, and then on the right side, negative 1 minus 7 is?
Negative 8.
Negative 8. Okay, good. Then what?
Divide by 2.
Okay, this is negative 2 times a. Common mistake here is adding 2 to get rid of that negative 2. But it's a negative 2 times a, so we need to get rid of it by dividing. So we divide by negative 2 on both sides. And when those negative 2's cancel each other out, what does that leave?
A.
And on the right side, negative 8 divided by negative 2?
4.
Positive or negative?
Positive.
Positive 4. Good. So this is the same type of problem because when we circle the variable, we notice that we have e's in two different places. They are both on the same side, though, which is important. If they were on different sides, then we would have to do something else, and we'll talk about that later. What do I need to do first in this equation to solve this equation? Yeah, I'm going to have to distribute here. I cannot combine like terms right now. I can't combine the 3e and the negative 2e because this 3e is inside of this group, this parentheses that's being multiplied by 2. All right, so we do need to get rid of those parentheses first, and we'll do that by distributing. So we do 2 times 3e, which is 6e. And then we do 2 times negative 4, which is 2 times negative 4? Negative 8. Then do I need to do 2 times negative 2e?
No.
Why not? That's not in the parentheses, right? Alright, so since I don't distribute that 2 to anything else, what do I do with everything else? Just bring it down. Alright, so when we're simplifying here by distributing, we're just going to bring everything else down that doesn't distribute. So we've got our 12 on the left side and our minus 2e on the right side. Equal sign goes on that line of equality. Alright, then what? Should I get rid of that minus 8 now to get the e by itself?
No.
Not yet, because we still have the e in two different places, so we need to do what? Combine the like terms, exactly. So we're going to combine that 6e and the negative 2e. What is 6e minus 2e? 4e. And then all that stuff that can't combine, just going to bring it down. So we've got our minus 8 there, equal sign on the line, and 12 over here. All right, now what? Yeah, now we just solve like we normally do. So we're going to add 8 on both sides. And the right side, the 8's cancel, leaving what's left after the 8's cancel on the right side? 4e. And on the left side? Okay. Then what? divide by 4. And when those 4's cancel, that leaves e equals 5. All right, so let's go back to what we were doing last week. In this equation here, what's different about this equation? It has that square root in it, right? And we need to get rid of that square root just like we need to get rid of those other numbers with the n. So we have to get rid of the 4 and the 2 and the 7 and the -5, but we also need to get rid of that square root. And one thing that's really important here is that we can't get rid of things that are inside of the square root until we get rid of that square root. All right, so to remind ourselves of that, we're going to put our box around the square root. Okay, so we need to get that square root by itself, and then once we get the square root by itself, we'll get rid of it before we can get rid of that stuff inside of the square root. So what two things are we going to have to get rid of before we can get rid of the square root? The 4 and the 5. Okay, so we're going to start with those two things. Which one should we do first? The 5. So how do I get rid of that -5?
Add 5.
All right, so we add 5 on both sides. On the right side, the 5's cancel and everything else comes down, right?
Yes.
So we got 4 square root of 2n plus 7. And on the left side, we get 20. Okay, so we got rid of the 5. We still need to get rid of the 4. And so how are we going to do that? Divide by 4 on both sides. And when the 4's cancel, we still have the square root. So on the right side, we have the square root of 2n plus 7. And on the left side, 20 divided by 4 is?
5.
Okay. Now we have the square root by itself. So what can we do with that? Yeah, to get rid of a square root, the opposite of a square root or the inverse of a square root is a square. So we're going to square the square root. Remember, squares go up and to the right. If I square the right side, I have to square the left side. So make sure we square both sides here. The square and the square root are going to cancel each other out, which leaves what on the right side? 2n plus 7. And on the left side, 5 squared is 25. All right, so there's our new equation. Now what? Subtract 7. And when those 7's cancel on the right, we get 2n. And on the left side, 25 minus 7.
18.
Okay, one more thing.
Divided by 2.
Get rid of that 2 by dividing. So we divide by 2 on both sides, and we end up with n on the right side and 9 on the left side. All right, this last one here, like I said earlier when you were getting started, this is not something we've seen before. What does this symbol right here mean?
Less than.
It means less than. So it means that whatever's on the left side over here has a smaller value. It would be farther to the left on the number line than whatever's on the right side of that. So 2x is less than 8. When we solve inequalities, it's a lot like solving an equation, except these two things are not equal to each other. This does not have the same value as this. This is going to be less than this. All right, so everything we do to solve this is going to be the same as solving an equation, except we're not going to use an equal sign. We're going to keep that less than symbol. Now, there are some things or some types of inequalities that we're going to have to do some kind of different things with, but this one's pretty straightforward. If this was an equation, what would I do to get x by itself? To get x by itself, I'd have to get rid of this 2, right? How would I get rid of that 2? We would divide, right? Since it's 2 times x, we would get rid of the 2 by dividing. So when I'm solving an inequality, I'm going to draw my line of equality. It's not really a line of equality anymore. It's a line of inequality. But I still want to keep my left side and my right side separate from each other, so I want to make sure I keep that organized. And I'm going to get the x by itself just like I always do. So how do I get that x by itself? Divide by 2. So I divide by 2 on both sides. And just like when we solve equations, those 2's cancel and I get x over here. And on the right side, 8 divided by 2 is 4. But do I want to say x equals 4? No. X is less than 4. All right, so what does that mean? What's a possible answer for x? There's actually a lot of them. It's 2, because 2 is less than 4, right? So what that means is if I pick any number less than 4 and plug it in here for x, this inequality right here is also going to be true. So since 2 is less than 4, I can put 2 in here for x. 2 times 2 is 4. Is 4 less than 8? Yeah, so that's true. What if I picked a number that's not less than 4? Let's say I pick 5. Okay, so it doesn't work here, right? So if I put 5 in for x, what's 2 times 5? 10. Is 10 less than 8?
No.
No. So if it doesn't work here, it's also not going to work here. So when we're solving an inequality, it's the same idea as solving an equation, except we need to make sure that we keep the symbol here. There are going to be some times where we're actually going to flip it. Instead of being less than, we're going to change it to greater than, and we're going to see an example of that tomorrow. But I want to just keep it pretty simple today. We're not going to be spending much time in class working on inequalities, but it is something you'll see on Khan Academy. So I want to kind of introduce you to it so that you know what to expect when you see those there. So like I said, when you're solving inequalities, do everything you would do when you're solving an equation, and we'll talk tomorrow about when things are going to change, when we're going to have to flip that inequality from less than to greater than, or